Alrighty. So the last couple of features that I really want to talk about ES2015 is actually going to require something called a polyfill. So a polyfill is basically a JavaScript compatibility layer, I guess you could say. So some of the things that I want to talk about here, namely symbols, iterators, and promises over the next couple of videos, are actually going to require bits of the JavaScript runtime to support it. And unfortunately, for browsers that do not have these features, Babel can't just translate the code that we write into something that'll work on these other browsers. Babel's going to need some supporting runtime to make it compatible. Now, some browsers will support these features natively, and generally what polyfills will do is they'll defer to the native implementation of the browser if such an implementation exists, but if it doesn't, it'll go out and it will kind of fill in those missing features. So we will need to use a polyfill. And the polyfill we're going to use is going to be part of Babel, and it's specifically it's mostly core.js with some Babel-specific stuff in it. So core.js is this really nice little polyfill that'll include a lot of ES2015, ES5, and even ES7 features that will allow you to use these features in your application without having to worry about browser compatibility. So let's go ahead and install the Babel polyfill. Not surprisingly, the way that we're going to do that is by opening up a command line window and coming over here, and I'm going to type in npm install. I bet you guys didn't see that coming. Babel polyfill, and I'm going to do save dev. Now the Babel polyfill, what we're going to do is we're actually going to reach into the node modules itself, and we're going to grab the polyfill.js file and serve it publicly. And then we're going to include the polyfill in with inside of our HTML page. And once it's available on our page, then we can use features in Babel that depend on the polyfill. Of course, we could not import the polyfill into our page, but then Babel will start compiling code once we use these features that simply won't work on older browsers that don't support it. So let's open up our node modules, and a bunch of modules here. I'm going to go ahead and grab our Babel polyfill, and I'm going to open up its dist directory, and I'm just going to grab polyfill.js or polyfillmin.js, whichever one. I'm just going to hit Control-C on it, and then in my Solution Explorer, navigate over to public scripts, and, let's just dump it right here in public. Frankly, I don't really care where it goes as long as we can include it. So I just pasted it in right here in our public folder. Now, be sure to do that, be sure to have it inside of your public folder so that it gets served out so our browser can require it in. Then what I'm going to do is I'm going to go ahead and click on O5 classes. I'm going to copy and paste it, and I'm going to rename it to the specific topic that we're going to be talking about in this video. So it's going to be O6-symbols. So once we have symbols in, before I include jQuery, I'm going to add another script tag. I'm going to say script source equals, I'm going to say / polyfill.min.js. Then I'm going to change the individual script we load in from O5 classes to O6 symbols. Now that the polyfill is available, we can now safely use quite a few awesome features from ES15, even if our browser doesn't natively support it. So this pretty much completes your installation of Babel, I guess you could say. So let's go ahead and jump open source scripts, and I'm going to right-click, new file, create an O6 symbols.js, and I'm going to do that awesome little split screen thingy here. Give me a sec, and that is open, and then I'll collapse that. All right, so I'll also go full screen. So symbols, what are symbols? Simply put, a symbol is a way to prevent other objects from accessing certain properties on your objects. Now, I'm sure you guys are all familiar with ways to deal with accessibility inside of JavaScript. I mean, for example, you might create a class like function myThing, and you might have like local variables like local var equals 10, and you might say return print console log local var. So that's a way to prevent anybody who gets this object back from invoking myThing from editing local var. Because if you didn't do it, you could edit it directly. For example, if I said const person, and then I said, or even better, you already saw this last time, where I have a class person, and he has a constructor that takes in a name, and then this name equals name, and then I can say const Nelson equals new person, Nelson. I can actually go in and say Nelson name equals whoa if I wanted to, and completely change that variable. But let's look at how we can fix that. So I'm going to go ahead and delete all this code, and I'm going to create a symbol. So I'm going to say const my symbol equals symbol my symbol. So let's take a quick look at this code. What I'm doing here, first I'm creating a constant variable called my symbol, and I'm invoking the symbol function, and I'm passing in a string. Now a symbol, what's interesting about symbols are, every time you invoke that symbol constructor thing, you'll get back a new object. All right, so for example, if I did const my symbol 2 and created a new symbol, and I passed in the exact same string into that, and then I did a console.log my symbol equals my symbol 2, and I came out here and I executed that, what do you think the output's going to be? Well, it's false. That's because every single time you invoke symbol, no matter what you pass in as the textual description of your symbol, you get a new object. So why is it important at all? Why even deal with symbols? Well, let's say I create an object. So I create my person. And inside my person, I want to go ahead and create a private field. So what I can do is I can do my symbol. Now notice the brackets here. Now the brackets here indicate that we're doing a computed variable. It's equivalent to if I had done person at my symbol equals, but instead I'm going to use the new object literal syntax. I'm going to say my symbol, and then I'm going to say equals bleh, and then I'm going to say render console log this my symbol. And now I can say person.render, but if I try to say console log person.mySymbol, I would get an error. Well, I would get a undefined. So let's come here and refresh. Notice how person.render worked properly. It rendered out bleh. But console log person my symbol doesn't exist. It doesn't exist at all. So basically, the whole concept of a symbol is that it's a new way to index objects. So you're familiar with indexing objects with strings. Like for example, if I said person hey equals whoa, right? As well as literals, which have the same effect. Symbols are simply another way you can reference a property on an object. Now, once you create a symbol, that is its unique instance. It is a unique object. Every time you create a symbol, the text inside of here is for debugging purposes only. The name you give it is irrelevant. Every time you create a new symbol, you get a new object. When you index an object by that symbol, you're basically accessing a private location within that object. So now let's, for example, imagine that we exported this person class or this person object into a different JavaScript file that doesn't have access to the symbol object that was created. Now it can no longer access that private variable. So let's take a look at that. If I go ahead and console log out my person completely, just straight up console log it out, come here and hit refresh, notice how we have symbol my symbol bleh. So that means that Chrome has support of symbols built in. Chrome will never allow me to access this variable. But how does what about browsers that don't support symbols? How does that polyfill work? Well, if I pop open Internet Explorer, not Edge, because I believe Edge does support symbols. If I go ahead and pop open Internet Explorer, I believe this is 12, and come back here and run this example and open up my console, and I open up the object. So remember, this browser does not support symbols natively, so how does the polyfill fix it? Well, the polyfill basically just uses a random number. So you can see here that we are, the symbol was created using a random string of text, and as well as the name of the symbol itself that I passed into the constructor. So with these browsers, it still is possible to access these private, quote unquote, properties, but it's very difficult because those symbols are going to use random sequence of characters to set those properties. So again, symbols are an awesome way to create private fields. They're also used in something we're going to see in the next video, and that is special built-in symbols to the JavaScript runtime are recognized for special purposes, and we'll see that in the next video. So there's not a whole lot else to say about them. Symbols are simply a way to namespace or make your properties private. They're also a way to hook into other things, into other JavaScript engine related things. Another good awesome feature is, let's say we're writing a jQuery plugin and we need to store data on the jQuery object. So I could say const my state equals symbol plugin x state, and then I could access the jQuery object and say my state equals, you know, custom value. And now I'm positive that no other JavaScript or jQuery plugin would accidentally overwrite that special property I made. The only code that can access that special property is code where this literal value is accessible from, which it won't be accessible from anything outside of this file because we have a self-executing function here. So anyway, that's the basics of it. I'll wrap up with a simple how to create a private field in using the class syntax. So for example, I can say something like const first name equals symbol first name. Really, the text you put in here is completely inconsequential. It's just used for debugging purposes. Then I can say last name equals symbol last name. And then I can create a class person, and get first name is return this first name, and then get last name, return this last name. And then I can create the constructor that takes in a first name, a last name, and then to set it, we simply say this first name equals first name, and this last name equals last name. So this is a way to create basically private fields. There's no way to edit these fields from outside of this one file. So we're encapsulating the data. So anyway, that's how you simulate private fields in JavaScript. We'll see more in another interesting example in the next video. But again, like I said, not a whole lot to say about symbols. There's a whole symbol API you can go look up on MDN if you're interested. Things like listing all the symbols that are used in the object and all that fun stuff. There's also a public symbol registry if you wanted to share symbols with other files. But that's not going to be something that you would do very often, if at all. But that wraps up this video, and we'll see you guys in the next one.